Sales of Grant's packs of 12 nozzles have really taken off. In fact, he's been doing so well selling these bulk packages that he's only going to sell nozzles by the dozen now. That does mean, though, that depending on how many nozzles he has total, he might have some left over. For example, if Grant has 40 nozzles total, then that will make 3 1/3 packages of 12 nozzles. Since if we take 40 and divide it by 12, we get 3 1/3. Now we can see these 3 whole packages of 12 nozzles, but then there's this 1/3 of a package left over. Grant can't sell 1/3 of a package, so this 3 1/3 packages really only counts as 3 for him. So it's almost as if we're taking this 3 1/3 and rounding it down to the nearest integer, 3. So let's say that x equals the actual number of packs of nozzles we have. So for example, in this case, we have 3 1/3 packs of nozzles. And let's say that y equals the number of packs of nozzles that Grant can actually sell. So in this case, that was 3. We can represent this relationship between the actual number of packages we have and the number Grant can sell by something that's called the floor function, also known as the greatest integer function. The notation for the equation is this: y equals x inside these double square brackets, which basically means that the y value is equal to the greatest integer that is less than or equal to the corresponding x value. But what do you think the graph of the floor function looks like? Which of these graphs do you think properly represents the floor function? Remember that we want the y value to round x down to the nearest integer. I know that from far away it might be hard to tell these two graphs apart, so below them I've shown a blown up version for you of what each of these steps looks like. Please notice the difference between the two in terms of which circles are empty and which ones are colored in.